Welcome to the Fungisphere webinar series, brought to you by the Sydney Infectious Disease Institute here at the University of Sydney. I'm Associate Professor Justin Beardsley, and it's my pleasure to introduce these talks, our passionate team, and share some of our mission with you. We're dedicated to increasing our understanding of all things fungal, be that human health, animal health, agriculture, ecology, or even the productive and industrial use of fungi. We are seeking to uncover the threats and the promises offered by these remarkable organisms. This webinar series is more than just a series of talks. It's a platform to bring experts in the field together to share their knowledge and hopefully to build new connections. It's a testament to the synergies that exist between researchers here, but also colleagues globally. Through these talks, we share some of the incredible work being done here in the University of Sydney, but also provide a platform for international experts to share their groundbreaking research too. So, whether you're a seasoned researcher, a student, or simply somebody with an interest in the fascinating world of fungi, you'll find something of interest in this webinar series. Together, we're going to explore the threats and the promises of the fungal world. In this talk, Dr. Maryam Roudbary from the University of Sydney talks about natural compounds, nanoparticles, and antimicrobial peptides as alternatives to antifungal drugs. She discusses her past work and outlines some promising avenues for future research. So let's hear from Maryam.
Hello, everybody. Thanks so much, Justin, for this introduction and to invite me for my talk today. And the title of presentation, I'm gonna talk about novel agents for treatment of fungal infection. What is the recent research and the future direction for this field? So for this talk, I'm gonna talk about introduction to fungal infection and therapeutic challenges, current available antifungal drugs and some limitation in this field, and what is the present situation in research with novel antifungal drugs and future perspective and direction. The first question is, what is the current issue for treatment of fungal infection? As you know, fungal infection cause millions of deaths annually over the world, and the rate of fungal infection in immunocompromised patients is dramatically increased. For example, in HIV patient with organ transplantation, patient who are under chemotherapy or radiotherapy or long-time hospitalization, all of these factors prone the patient to get fungal infection. On the other hand, we faced with a limited number of commonly used antifungal drugs for treatment of fungal infection, and also the emergence of resistant fungal isolated is a big challenge for treatment of fungal infection in clinical settings. So with this all challenging issue, we have to search for alternative and other kind of treatment to combat fungal infection. As you know, there are three or maybe four main category for antifungal drugs for treatment of patients with fungal infection, and mainly they are classified as azole, echinocandin, and polyen. And unfortunately, with the emergence of multi-drug resistant fungal isolated, we witness some antifungal drug resistant to clinical setting and some difficulty for therapeutic outcome in patient. Azole is the class of antifungal drugs that mainly used for opportunistic fungal infection, and the mainly of them are fluconazole, voriconazole, posaconazole, isavuconazole, and the mechanism of action of this class of antifungal is inhibition of the main enzyme contribute to synthesis of ergosterol in the cell wall of fungal cells. On the other hand, on the other side, some fungal species use some extra mechanism to overcome for drug susceptibility in clinical settings, and mainly non-candida albicans species are really resistant to this class of antifungal drugs. Also, the second one is echinocandin, caspofungin, micofungin, and anidulofungin, with another kind of mechanism of action by inhibition of the main polysaccharide component of cell wall of fungal, include 1 and 3 beta-glucan synthetase, and this class of antifungals actually are fungicidal effect against fungal species, and also pollen, mainly amphotericin B, that fortunately some species are even susceptible to this class of antifungals. In this slide, you can see the intrinsic and acquired resistance against commonly used antifungals drug in clinical settings with different mechanisms. The fungal cell can acquire resistance to commonly used antifungal drugs. Some of the main mechanisms include using the efflux pump that cause the pump out the drugs, the outside of fungal cells, so the antifungals cannot affect properly, and maybe with some alteration in cell permeability, the effectiveness of antifungal drugs will be decreased. And with all these problems, and the other side, the emergence of resistant fungal species, so the effectiveness and the use of commonly antifungal drugs have been faced with some issue for treatment, for appropriate treatment in patients with fungal infections. So how we can address this problem for overcome this issue? Development of new antifungal drugs with using novel mechanism of action is always gained some attraction for researchers in medical mycology. And also the novel antifungal agents, the research related to novel antifungal agents are undergoing, and with view the past and the recent research, we can see some development and improvement in this field of mycology with different publication in different area for overcome the resistant to available antifungal drugs. So in this talking, I'd like to categorize the novel and promising alternative options to treatment of fungal infection to 3 categories, including nanoparticles, natural compound, and finally antimicrobial peptides for some research in mycology against resistant fungal isolators. I'm going to start with nanoparticles or nanomaterials and the current progress in the medical mycology with introducing some published articles from our team in Iran and nanoparticles marked as a next generation antimicrobial agents. And currently, many directions for research, development, advancement for antifungal nanomaterials are undergoing, and even to enhance the effectiveness of nanoparticles, some chemical modification and combination with commonly used antifungal drugs are very promising finding in this field. The main classes of nanomaterial are categorized to inorganic particles like silver, zinc oxide, selenium, iron oxide, and also organic nanoparticles like liposome, micelle, and nanoemulsion, that the recent research are really focused on these organic nanoparticles and also hybrid nanostructure like composite nano-antifungal agent that our group in Iran mainly used this structure of nanoparticles against resistant isolated of fungal species. So generally, mechanism of action nanoparticles, I can summarize it. Nanoparticles can surround the cell wall of fungal species by attachment to the cell wall or maybe to cell membrane and form some pores in the cell membrane and can enter the cytoplasm of fungal cells, and after that maybe some of the nanoparticles can bind to DNA or to RNA of fungal cells, and with different mechanism they can cause the death of fungal cells. Apart from yeast cell, also some research focused on the application of nanoparticles on saprophytic fungi like Aspergillus, Penicillium, Fusarium, and so on, with promising finding. So I want to start with my research team in Iran, with my students in the lab, with some research on nanoparticles and design and synthesize of mucoadhesive nanogel containing farnesol. We have done this research work for my PhD student in the lab in Tehran, and we used the farnesol as a signaling molecule that produced by Candida species, and it mainly suppressed the biofilm formation in Candida species. And for enhancement the efficacy of farnesol against fungal species, we used the nanoparticle combined with farnesol to enhance the efficacy of farnesol against the fungal species. As you can see in this table, when farnesol combined with nanoparticles like chitosan or alginate, the MIC minimal inhibitory concentration decreased, and they can affect against Candida species very well. And in this series of research work, we had some view to mechanism of action. Some nanoparticles mainly focused on the evaluation of these nanoparticles on some gene expression related to biofilm formation as a first step to pathogenesis of fungal infection like candidiasis. And in this work, we evaluate the effect of the activity of this nanoparticle for expression of high fiber protein and secret protein SAP and the other genes related to pathogenesis, and progress the infection with promising result. In the other work, we also had some research for antifungal effect of indolecidine as an antimicrobial peptide conjugated with gold nanoparticle, because indolecidine is an antimicrobial peptide with short lengths and with some beneficial effects against a wide range of microorganisms like fungi, bacteria, and virus even. And I'd like to explain this antimicrobial peptide well studied against bacteria in literature review, but even in terms of fungal infection, we have really need some extra and further investigation to approach antimicrobial peptides against fungal species. On the other side, we use the gold nanoparticle as this kind of nanoparticle is safe and less toxic for human cells, and with conjugated indolecidine and gold nanoparticle against fluconazole resistant strain isolated from patients with burn infection in Iran. We have seen some promising results, and you can see in this table free indolecidine with MIC about 50 microgram per ml when it's combined with nanoparticle and conjugated indolecidine and gold nanoparticle, the MIC really decreased, and it's very good candidate for overcome the resistant candida, the resistant isolated of candida, and also the MFC minimal fungicide concentration also decreased compared to free indolecidine. So with this result, we can introduce this conjugated nanoparticle as a good candidate or alternative agent to fight against resistant isolated of candida. And also in this research work, we had a view to evaluate the cytotoxicity effect of conjugated indolecidine with gold nanoparticles, because it's very critical to know how is the effect of nanoparticles in cytotoxicity effect against the human cells for the further investigation in vitro and in vivo model in the future for clinical trial, because the cytotoxicity effect is very crucial, and fortunately conjugated indolecidine in different concentration had not showed any significant cytotoxicity compared to untreated cell with no exposure to nanoparticles. So we can say this nanoparticles can be safe for epithelial cells. In the another work for my master students in 2018, we synthesized and characterized the antifungal of novel formulated nanocomposite containing indolecidine with graphene oxide, another kind of nanoparticle. And in this work, we also evaluate the effect of these nanoparticles in vivo model, in mouse model, and with promising outcome. In the top right side of this slide, you can see the SEM, scanning electron microscope image from the graphene oxide, and also you can see some histopathological graph from the tissue, different tissue in the mice after exposure with these nanoparticles. As you know, working with animal model for evaluation, the effect of nanoparticle is also challenging, and this work is it was really we faced some problem for infection of mice model for invasive candidiasis, and because the survival rate in the mouse is very critical after exposure to nanoparticles. Also in this work, when graphene oxide combined with indolecidine as antimicrobial peptides, the MIC really decreased against candida species. In another work, we performed another research work in vitro antifungal activity of nano-encapsulated caprylic acid with evaluation the gene expression by real-time technique in Candida albicans, and the nano-encapsulated caprylic acid really the MIC significantly decreased compared to caprylic acid alone against Candida species. And also this compound successfully decreased the gene expression related to biofilm formation as the main step for pathogenesis of Candida and also the other kind of fungal infection. Also in this work for my PhD student, we used the zinc oxide combined with ketosane as a polysaccharide, biocompatible polysaccharide, in combination with linoleic acid with some of antifungal effect and with different concentration of this novel nanocomposite. We evaluated the cell viability of this component against some cells, and fortunately no significant difference had been showed when the cell's exposure to these nanoparticles because sometimes nanoparticles may be toxic for epithelial cells, but when they conjugate or combined with another component, the cytotoxicity will be decreased, and we can see the less cytotoxicity against the epithelial cells. And also for having a view the probable mechanism of these nanoparticles, we examined and measured the ROS production for macrophages from mice, and with different concentration. As you can see in this graph, the treated cell with dark gray, when they exposure with this nanocomposite, the production of ROS will be increased compared to cells without any exposure to this nano compound. So as a probable mechanism of these nanoparticles, we can say by increment of ROS production by macrophages, they can act a good candidate against fungal infection. With this research work, still there are some limitations for application of nanoparticles in clinical setting, and as I explained and mentioned previously, the silver nanoparticles, the most researched nanoparticles with reviewing the literature, and also there are some limitation for using this kind of nanoparticles, like irreversible pigmentation in the skin, maybe in the clinical application, and also damage to kidney or liver or other organs, and high toxicity to host cell. However, for these all limitation, we can use other alternative options to decrease the limitation of the nanoparticles, because they potentially have a good and reasonable antifungal effect against even resistant fungal species. And also for zinc oxide and magnesium and selenium, also there are some promising result as a good candidate for antifungal drug-resistant species in the literature. And however, for nanoparticles application, always the level of the amount of nanoparticles is very crucial, and with the increased dose of nanoparticles, the cytotoxicity effect against the human cells may be increased. Also, other kind of nanoparticles like tellurium and also iron compound are promising have promising result in nanotechnology against fungal infection, and however they need high concentration, and they cause long-term toxicity. So we are the first way of using nanoparticles, and we have to expand our research in this field to receive some acceptable result for using the nanoparticles in the future research works. What is the future direction related to nanoparticles? As I mentioned, systematic research on the different aspects of nanoparticles are required to check the potential toxicity, and also for to receive and to gain the effective concentration of nanoparticles to less the cytotoxicity of nanoparticles for clinical use in the future, and also more and more in vitro and in vivo investigation are needed for applying the nanoparticles for antifungal treatment in the future, and new approach for synthesis and modification methods like combination with commonly used antifungals are also bring some beneficial effect for therapeutic option. The second one that I would like to talk about for as a novel antifungal agent is natural compounds, and we had done some research for natural compounds in our research team in Iran, because Iran has a old history for using plant and herbal medicine against different infection, and also different application of a natural compound like plants, and mainly essential oil as a source of antimicrobial agent, and is an interesting solution for combat against emergence resistant fungal species, and also antibacterial property of the essential oils always gained many attraction by researcher. Also the studies related to natural compound like nanoparticles are promising. Always other challenges that may researcher have faced with this kind of antifungal agents is always important, like toxicity of the some products, and some patient may be allergic and show some allergy sign when using the natural compound, and with all these challenges, we can even use the natural compound as a promising agents against fungal infection. So many works to be done for have a broad view for using essential oil in medical treatment and for treatment of fungal infection is really crucial, and they remains a good candidate for future direction, and having a deep study regard to mechanism of action of this compound is really helpful for next step and for next direction for using the natural compound like essential oil against fungal infection. And so mainly in our research, we used thymol and also carbacarol and also cinnamon aldehyde as essential oil of some plants in Iran for our research works with different mechanism of action against different fungal species like yeast, Candida, and saprophytic fungi like Aspergillus flavus, Aspergillus fumigatus, and mainly thymol and carbacarol with the interesting mechanism of action by binding the ergosterol of the cell wall of fungal infection. They can alter the permeability and they can cause the osmotic imbalance and they can inhibit the hive growth as a main step for progress the infection. So they can target the different kind of fungal cells with different mechanism of action and also affect on the virulence factors related to pathogenesis of fungal infection. In 2023, we performed a research work combination of farnesol, as I mentioned previously, as a signaling molecules with common antifungal drugs and against the clinical isolated of Candida albicans. And farnesol importantly decreased when combined with antifungal commonly used drug like itraconazole, fluconazole, and amphotericin B importantly decreased the MIC of this drug. And in this work, we used the resistant candida isolated from women with vulvovaginitis candidiasis. As you can see, when farnesol combined with itraconazole and amphotericin B and ketoconazole, the MIC in combination will be significantly decreased and overcome. So it can overcome the resistant isolators. Also, the combination of farnesol with common antifungal drugs enhance the activity of the fluconazole as the main azole for treatment of fungal infection in patients with VVC and suggesting it might be a promising antifungal agent as a natural component because it can be produced by fungal cells like Candida and even produced by other plants. We use the farnesol alone for evaluation of the cytotoxicity effect against some cells in vitro evaluation actually, and it hadn't showed any cytotoxicity effect compared to non-treated cells. Also in recently work, we evaluate the thymoquinone antifungal activity against Candida glabrata as a WHO priority pathogen by the WHO, isolated from the patient with oral candidiasis in ICU ward, and thymoquinone is another essential oil extracted actually from the traditional plant in Iran named black seed, and this kind of essential oil is very applicable for treatment of different diseases, a wide range of diseases like anti-inflammatory effect, anti-aging, anti-cancer activity. And for this work, we used this essential oil as an antifungal agent. Candida glabrata as a high priority pathogen for WHO, and on the other side, thymoquinone as a very good candidate essential oil. We showed a promising effect, as you can see in this table, thymoquinone with MIC 50 and fluconazole, all of the clinical isolated of Candida glabrata were resistant to fluconazole, and when exposure to thymoquinone, we showed a decreased MIC against them, and also the majority of the Candida glabrata isolated were resistant to itraconazole, and some of them were resistant to amphotericin B, and also amphotericin B is a good drug for treatment of Candida glabrata, and 100% of isolated treated with thymoquinone at MIC concentration showed a statistically significant downregulation of one main gene contribute to biofilm formation. So with inhibition of this EPA6 in Candida glabrata as a main and key genes associated with biofilm formation is a very promising compound for inhibit biofilm formation for this high priority pathogen. So thymoquinone has the ability to reduce Candida glabrata biofilm formation, and maybe it's a molecular interest for the future as a novel adjunctive agent to fight oral candidiasis. So another works, we combine thymoquinone as a natural component with zein nanoparticles with the promising MIC against Candida albicans. And as you can see in this table, when thymoquinone combined with nanoparticles, the MIC significantly decreased with the promising outcome. Also, we had a view for the mechanism, the probable mechanism of thymoquinone combined with zein nanoparticles to production of total oxidative status as a main pathway for death of fungal cells, and the level of TOS increased when the cells exposure to this nano compound. So with induction ROS and nitric oxide, they can cause the cell death of fungal pathogens. So the last one is antimicrobial peptides, and the question is: are these kind of antifungal agents, novel antifungal agents, are a promising therapy in the clinical setting? As you can see in this slide, AMP can act with different mechanism, and they are and the origin of AMP from the natural sources or maybe the synthetic in the lab, and also the different application of AMP in food application, in plant protection application with different structure. Actually, the different structure of antimicrobial peptides can affect the mechanism of action and the activity of nanoparticles, and the length of AMP is also very important to exert antifungal activity, and in this slide you can see the different mechanism of antifungal and antimicrobial peptides with inhibition of DNA synthesis, inhibition of protein synthesis, and maybe some changes in protein folding, and also they can attach the cell membrane of fungal cell, enter the cytoplasm, and also they can cause the death of cell wall. Also in this slide, you can see the different probable mechanism of antimicrobial peptides with some membrane damage, with formation pore in the cell membrane, vacuolization and vacuolar expansion, and also production, lots of amount ROS that is very toxic for fungal cells. So antimicrobial peptides with anti-candida activity can bring us some promising finding against fungal infection, and I summarize some of the peptides with human source like defensin, histatin, and LL37 are the main human AMP against fungal infection, with different effect on planktonic, sessile, and even biofilm formation in fungal species, and also psoriasin, and the beta-defensin mainly 3 is used for clinical setting for treatment of fungal infection. So what is the future perspective with antimicrobial peptides? However, the bioavailability and low metabolic stability of AMP restrict the use of the AMP in the clinical setting. They are still a good candidate against fungal infection because the range of the resistance in against AMP is very low compared to commonly antifungal drugs, and with a great study on the mechanism of AMP for the bioavailability and the other aspects of AMP, we are able to get some further data related to using AMP in the clinical setting, and some of the AMP being brought to the clinical trial like nicomycin, aerobazitin, and also VL 2397, and also finding some patients who are eligible for clinical trial. Always maybe we face some difficulty for finding that kind of eligible patient. And the last one is novel antifungal agent in the various phases of clinical development as a novel antifungal drugs like rezafangin with the class of glucan synthetase inhibitor, and also ibexafungerp with inhibition of beta-glucan as the main component of the cell wall of fungal cells, and fortunately they can act against invasive aspergillosis and candida as the main opportunistic pathogens in immunocompromised patient, with some benefits and no hepatotoxic compared to old classes of antifungal, and even oral and IV formulation against resistant fungal infection. And also in this table you can see the other novel antifungals with different mechanism, and they can distinguish between the fungal and mammalian cells enzymes, so they they can act targetedly against fungal infection without any harm to host cells. And also another new class of antifungals named fosmanogepsic, that this kind of antifungal can inhibit the GPI, glucosyl phosphatidylinositol, in the cell wall of the fungal cells, and they can act against a wide range of fungal infection. And also finally, chitin synthetase inhibitor is another class of novel antifungal drugs against to some dimorphic fungal species like Coccidioides, blastomyces, and so on.
Do you have a summary slide? Sorry, we have to finish it.
Yeah, this is the conclusion.
Amazing.
Yeah, thank you. So in conclusion, taken together, we can conclude this talking. The incidence of multi-drug resistant species is increasing, and the number of immunocompromised who are prone to fungal infection is dramatically increased on the other side. So finding, searching, and looking for some novel antifungal agents to fight against fungal infection is high priority for medical mycologists, researchers over the world. And research into these agents should focus on the mechanism of action and the preclinical trial for checking the efficacy, bioavailability, and probable toxicity, and also systematic research to have some idea for affordability and scalability and durability of these kind of novel antifungal agents. And thank you so much for your attention, and for any comment or questions.
Thank you, Maryam. That was most interesting. Right, we're going to change the camera setup here. Do we have any questions first? Maybe from in the room? She's been a little neglected.
Yeah, thank you so much. That's so interesting. So can I ask about the TQ, I think it was?
Thymoquinone.
Yes.
Yeah.
So with the MIC, they reported on 50 to 100. So is it toxic? Is it toxic to humans? Do you only foresee, is that a topical agent? Because the study you showed was for topical, it was for oral candida, wasn't it?
The main aspect of using all novel antifungal agents, we have to check the cytotoxicity effect for further investigation in model. And for thymoquinone, we checked the cytotoxicity effect at the MIC concentration, and it was safe compared to, So we can use some natural compound. Some natural compound for in vivo model. For example, all of our research work restricted to in vitro model, except one, graphene oxide combination with indolecidine. We also evaluated the in vivo model. For thymoquinone, we haven't done any research for checking the bioavailability and the safety in the mice model. But in vitro, it was totally safe against the epithelial cells with no cytotoxicity.
Yeah, thank you.
You're welcome.
Any other questions in the room, or we go to online? Okay. Anybody online, you can just go ahead and unmute yourself, or that would be the easiest thing.
Hi, Justin. I have a question.
Please, go ahead.
Yes. Okay. Thanks for the interesting talk, Maryam. You spoke about various ways of combating antimicrobial resistance in fungi. Has anyone used any fungi-specific viruses for this purpose? Because for bacteria that are multi-drug resistant, people have already explored using bacteriophages, which are bacterial specific viruses for treating them. Has anyone done the same for fungi resistant viruses?
Um, For our research that I explained you in the slides, we haven't done any research for the virus. Do you mean the virus that can combat against the fungal infection, right?
Yes.
We haven't done any research in this area, but to my knowledge, I know that there are some viruses with mRNA. They can fight against the fungal infection. Yeah, you are right, but we haven't done any research in this field.
Okay, I see.
Like bacteria, there are some mRNA virus that they can fight against the fungal infection. And we have published a review article in Farsi, in my native language, associated with virus to fight against fungal infection.
Do
Okay.
you know if anyone else has done that research?
No.
Because it seems that more people talk about bacterial phages
Yeah, very interesting area.
than fungi specific viruses.
Thanks for your suggestion.
Thank you.
Okay. Do we have any other questions? Mark?
Just got a quick question. So thanks for the presentation. I was interested in your discussion around essential oils, and I was just thinking about, you spoke about the problems of toxicity, and I suppose I was just thinking about how you're exploring that toxicity in those essential oils that might be apparently less toxic. And what I'm talking about here is that we've sort of established in koalas that some of these plant secondary metabolites can have direct toxic effects across many cells, but also some more subtle effects on immune function, immune cells. So I just wonder whether pursuing that essential oils pathway, whether you've thought about those compounds that are perhaps not as directly, toxic, what other effects they might have on the host.
Do you mean that the essential oil are not toxic for epithelial cells in host?
I'm asking about the range of toxicity that you're exploring.
Yeah. This is some challenging questions, and we mainly evaluate the cytotoxicity effect of nanoparticles and natural compound at MIC concentration. For example, when a component or the compound can inhibit the growth of fungal cell at MIC concentration, that's fine to show no cytotoxicity effect in the cells. With increasing the concentration of natural component or nanoparticles, it might to increase the cytotoxicity as well. So with combination of this natural component with nanotechnology carrier, for example, the lipid form or the other carrier, we can control the cytotoxicity at the best concentration for inhibition of fungal growth. I hope I respond to you well.
Thank you. Thank you.
Thank you for joining us. I hope you've enjoyed today's talk from the Fungisphere webinar series, and we look forward to seeing you next time.